Alright, this is my solar tracker, showing you one of them right here. Kind of give you some dimensions and things on the tracker itself. You can see it's a pretty good sunshiny day. I've generated more so far. It's about 2 o'clock in the afternoon, more than what I should have generated all day long. But I want to talk about the building of this. As you can see, the underside, it's all metal. Start off, if you've looked at the plans that I have set up for you, you can see that on the structure itself, it's pretty much a metal structure here. If you decide to build your own, you'll start off with that tubing that's underneath. That's 1.5 inch square tubing, 11 gauge. Make sure you get the 11 gauge, not the 16, because it's a lot stronger. Usually it comes in 24-foot pieces. And what I've got here is a 14-foot piece going from the top to the bottom. You can see that on both sides. I've got 2 of those, one on each side there of that. And then the other part of that, 10 feet of it, actually goes across from the top, on the top side, one in the middle, one on the bottom, right there. Those are welded together. When you get your metal to put that together with, you also want to make sure and get some of the bar. Now, I like the bar on here. You can see up there the bar running across the back, in the top, in the middle right there, and there's one also at the bottom that you can see kind of right there, that holds everything up. Now let me go over here a little bit so you can get a little better view what I'm talking about on this. The bar is welded to the bottom of the structure, down the bottom side, to the bottom of the metal on the top, and also across the top up that way. You can see it up there at the top. It's welded to that. That will give it a little bit more support, a little bit more strength to be able to hold up. This is 3-inch Schedule 40 pipe. On the outside there, you'll see 3.5-inch Schedule 40 pipe that's rotating inside of. I don't know if you can see it real well or not. I'll try to get a little closer. That's a collar right there, made of 3.5-inch Schedule 40 pipe with some 1/2-inch, 4-inch, 4-inch thick, 4-inch wide, 1/2-inch thick metal that holds everything up. It all rotates on that on the top, and that's all welded together. Now, I do want to caution you, before you get too far into it, you're going to want to make sure. Let's see if I can find some here on the camera. And back off a little bit. You can kind of see right there. You want to make sure before you put it up, to drill your holes in this metal. I didn't do that. That was a mistake. I had to drill all these holes, and you can see there's one on each one of the iron, the rails that hold the panels on. Had to drill those holes after I got it put up. Please make sure and mark those and drill them before you do anything else, before you paint it or anything. This is all mounted on here and welded to the bar. You can see it right there, welded there Starting to move a little bit. And there at the top, in the middle and the top, and underneath, that's welded to that. And you want to try to make sure and miss those holes right there. Now I've got a piece of that bar also that holds this last one on, so I could have 9 of the panels on here. Right now I've got 8 up the sides and 1 down here at the bottom. This is a 4-foot piece of the bar on the bottom piece here, and that kind of helps hold this last solar panel on. On the back, what I've done here, this was set up to allow it to move up and down for the seasons. Right now it's set up pretty much at the wintertime season. I didn't want to raise it all the way up because I thought it might be a little bit too high, and to keep it out of the wind. But from the parts list, that's 2.5 inch 3/16 metal that you're seeing there that's made out of the structure. And the structure itself is 8 foot of that 2.5 inch bar that's welded to a bar going across the bottom. That's 10 foot down at the bottom, 8.5 foot, and we've got a 2-foot piece there in the center. I'll get a little closer to it now so you can see it. And this is a 2.5 inch piece, and that's a 2-inch piece of schedule 40 going through there, so it's pretty sturdy, pretty rigid holding that up. Everything's welded, everything's pretty well painted. You can see my panels. They probably could be routed a little bit better. I'm still working on things. With the Envoy M250 microinverters on there to help with the shading and things. But there's this, and the bar moving down the center. Notice the cable on here too. The cable is here to keep it from sliding back. I actually put the ring on the wrong side up here at the top. You'll notice the ring here on the front of that. No problem with this going backwards. The problem is, or going forward, the problem is it goes backwards. So to keep it from going too far, when I raise it up and lower it, I actually put the cable on there because it will tend to slide back. I've got a U-bolt on there, and that's not really doing a whole lot of good. But this cable works pretty well to hold it together. All right, it's moved again, about every 3 minutes or so. What I would suggest is putting one of those rings on both sides and just welding it to the bar on both sides. We actually were going to use screws to hold it down, but it actually worked better to weld it to that once we got it together. So weld one of those on both sides so it won't slide when you raise it up. Right now it's about 30 degrees, something like that. But I can drop it down to about 25 degrees, and it does make a difference in the winter time, in the summertime, dropping that down. So I actually get a swing of the sun above and below it. Now, those are 8-foot pieces there. That's a 2-foot piece there with holes drilled in it in the center. The 2-inch square rebar, and it's all square, goes up the center so I can raise it and lower it. And there's a bar across the back there. You see that little bar there. I use that to put a come-along on there, and also in that hole right there to be able to raise it and lower it. And it works pretty well, raising and lowering. Just make sure you seal that up, and every once in a while come out and spray some wasp spray in there, because I did get stung pretty bad this spring, or this fall actually, when I tried to raise it up. Now down here, this is the actuator. That's a piece of 3.5 inch metal tubing right here. 3.5 inch. The 3 inch sits down inside there. This is angle iron right here. and it's welded to the very top, perpendicular to the panels. So when the actuator moves that, it'll actually be lined up with it, and kind of tell, you know, when it lines up with the sun. This, really, I should have welded it a little bit further down here. You only want about 1 inch of offset, and I've got a little too much offset, so I had to put a piece of the 4-inch Schedule 40 right here to kind of hold that off of there. And the actuator does a pretty good job moving everything. I've got some trees in the morning that kind of mess with things a little bit, so I don't really have it coming all the way over. Really, if you wanted it to be able to come further over, you might want to take that bar, drop it down a little bit more, and then make that bar across on top of this longer for a 36-inch actuator. This is a 24-inch actuator right here, and it works pretty well on that. This is welded here at the bottom, and this is a swivel down inside here. Notice I had to put a piece of wood inside here. This bolt is not quite the same size as what this is, so it wobbles a little bit when it goes past the center point. So you want to make sure that your pipe inside diameter is about the same as the outside diameter of your post there. This is a piece of Schedule 40, 3-inch pipe, the same thing that the mount's made out of, 5 feet long. I just bought another piece of it. I've got 4 of the trackers, and you can kind of see them down here. I got 4 of the trackers, so I bought another one of those, cut it up. It comes in 20-foot pieces. I cut it up into 5-foot pieces, drilled 2 holes in it so I can put rebar in there, welded 1/2-inch iron here and here to the bottom, and made a little cradle for it so this moves up and down. This is L angle iron right here, and it goes along the side and the bottom of that to hold that all up and give me a place to weld the side to. I really wanted to put angle iron on there, but that 1/2-inch stuff works pretty well. I would use angle instead of that though, because it won't flex at that point, and just use that instead. As far as how well it works, I'm getting about 40% more on each one than what I should have of the system. This is a 10 kilowatt system. On a good day, instead of having half an hour of peak, I'll get 5 hours of peak production out of it, and still get pretty good production in the evenings. So like a day I should be running about 28 kilowatts. I'll run about 60 when it's full sunlight like it is today. The plans for this are on. I'm going to put those online so you can build your own. You can use those if you want to. You can use something else. You can modify it if you do. I want you to let me know about that if you could. Also, please don't sell the plans. I'm going to put those on there for free. I don't want to make money on this. I want everybody to be able to use it. I have a plan. I've never seen a plan for these things online. Have any questions or anything, you can get in touch with me through the YouTube site. And please like my site and if you enjoy this video, if it makes any sense to you. Also, you might notice on one of my other sites, you can also ask questions. They actually pop up on my phone, so I can answer back pretty quick if you have questions on anything. And just good luck with your system. Hope it works out well for you. I really like what mine's done for my electric bill. And like I said, if you have any questions, please get in touch. Thank you.